All right, in this video lesson, we are going to be talking about evaluating functions. Here's a function right here in function notation. It's f of x equals 3x plus 2. Or here's another one, g of x equals negative 5x minus 10. Now, let's take a look at what is a function. So here you see this advertisement. It says $10 t-shirt sale. All right, so this could be considered a function. Here's what that would look like. We would say f of x equals 10x. What this is a function where the total cost is a function of how many t-shirts you purchase. So for instance, if I said I wanted to buy 3 shirts, then we would say f of 3 is simply equal to 10 times 3, which equals 30. So what we're doing when we evaluate this function, if we say f of 3, then we just plug 3 in here for x, and it's 10 times that, so 10 times 3 is 30. Now, you guys probably understand that if t-shirts are $10 each and you buy 3, you're going to spend $30, okay? Now, of course, that's before tax and all that, but this is what a function is. It's a function of the input, or the output is a function of the input. So, for instance, when you buy 3 t-shirts, the cost is $30. You have your x, which is your input, which is what we input into the function right here. And then we have your y, which is the output, which is what we got when we worked it out. Okay, so that's what a function is. And then we're just going to get some more practice evaluating functions. Okay, so here is an example. Okay, and it says that we have f of x equals 3x plus 5. So you could be asked to find anything. So let's say f of 5. Well, f of 5 would be 3 times 5 plus 5. And 3 times 5 is 15. And then 15 plus 5 equals 20. So what we know is that f of 5 equals 20. All we did is take that 5 and plug it into the function 3 times the x value. So 3 times 5 is 15, and then plus 5 is 20. Okay? So that is how you evaluate a function. Maybe just some more practice. This one says g of x equals negative 2x plus 3. Well, let's say we want to find or evaluate this function for, say, I don't know, negative 3. So let's say g of negative 3. Well, we're going to simply work it out, negative 2, and then times, we always multiply using parentheses, or we put the value in parentheses, and that's where we're going to replace the negative 3, and then the rest of the function is plus 3. So when we evaluate that, negative 2 times negative 3, we get negative 6, or positive 6, sorry. Remember, when the signs are the same, a negative times a negative is a positive. Just like a positive times a positive is positive. When the signs are the same, the output is positive. So negative 2 times negative 3 is 6, and then the rest of the function says plus 3. All right, and all of that equals 9. Okay, so that is a look at evaluating functions. And again, let's remember that this creates these ordered pairs. When we plugged in a negative 3, we got an output of 9. That's our x and y ordered pair. Now let's take a look at what this looks like on a graph here. So we have the graph of an equation or a function, okay? I don't necessarily know what that function is right now, but I see that it's graphed. So from a graph, you could also be asked to evaluate f of, say, I don't know, f of 5. Well, f of 5 is when the x value is 5. So if you know that x is 5, what you're looking for is the y value. Well, you look up here on the x-axis and you go 1, 2, 3, 4, 5, and you go down and you see that this graph intersects at -1. When x is 5, the y is -1. So therefore, we understand that f of 5 equals -1, or this value becomes -1. All right. So again, we could say that that becomes -1. That's how you evaluate a function for when you're looking at a graph. So again, what if I asked on this one, what if I said f of 0? What does that equal? Well, when you look at this graph, when the x is 0, that means we don't go right or left, it's 0. We look for where this linear graph crosses at when x is 0, the y is 1, 2, it's 3. Here's your 0, 3, right here is 0, 3. So we know that when f is 0, it equals 3. When we evaluate this function for 0, it equals 3. Now, let's look at this same graph, and let's look at functions a little differently. Let's say that we were told that f of x equals, let's say f of x equals -1. Okay? Well, what this is saying, remember that, or know that f of x is basically the same as saying y, the output. Okay, so this function of x is the output. Like, how much is it going to cost total based on how many t-shirts you buy, was that first example I showed you. So the f of x is basically the output. Well, in this example, it's telling you that f of x, or the y, equals -1. Well, if y equals -1, then you look down here at -1 on the y-axis. Here's -1, we go over. It's right here. Well, that's when x is 5. So if f of x equals -1, then what we know is that the x equals 5. So we got 5, -1. Okay, just like on the previous example, we evaluated 5, 1, 2, 3, 4, 5, and we went down to -1. When f of x equals -1, we can determine that x is 5. So that's two different ways of asking the same, or asking you to evaluate functions, all right? Or same thing on this example, if we said f of x equals 3, then what we know is that y equals 3. Well, if we know where y equals 3, then we can determine what the x is. We go over here, 1, 2, here's 3 on the y-axis, and we can see on the x-axis that it was 0. So we can determine that x equals 0. So we had 3, 0. Not 3, 0, we had 0, 3. The x was 0, and the y was 3. All right, and that's a look at evaluating functions.